Hello everyone. In this video, we will discuss another conic section, which we call the parabola. Let us define what is a parabola. A parabola is the set of points in a plane that are equidistant from a fixed point and a fixed line. The fixed point is called the focus, which is not on the parabola. So the fixed line is called the directrix. The midpoint of the perpendicular segment from the focus to the directrix is called the vertex of the parabola. And the line that passes through the vertex and the focus is called the axis of symmetry. Now, in the definition of parabola, it was explained that it is a set of points that are equidistant from a fixed point and a fixed line. So this definition means that if we get a random point, let's say P, on the parabola, if we get the distance of the point P with the fixed point, which is the focus, and if we get the distance of the point P with a fixed line, which is called the directrix, these distances are equal. Now, the vertex is actually the midpoint of the perpendicular segment from the focus to the directrix. And then the line that passes through the vertex and the focus is called the axis of symmetry. Now, the general equation of a parabola comes from the general equation of a conic section, which is given as follows. However, to determine if this is a parabola, we need to check if either A is equal to 0 or C is equal to 0. So it cannot be that A and C are both 0. So if we are given with a general equation of a conic section, we can determine if it is a parabola if there is a missing x squared term or a missing y squared term. Now, if y squared is missing, then the general equation would be a times x squared plus b times x plus e times y plus f is equal to 0. And in this case, the parabola opens upward or downward. So the orientation of the parabola would be either it is opening upward or opening downward. Now, if x squared is missing, then the general equation is c times y squared plus d times x plus e times y plus f is equal to 0. And in this case, the orientation of the parabola is that it opens to the left or to the right. Now, just like circles, now we can write the general equation of the parabola in the standard form. So the standard equation of a parabola would depend on the coordinates of the vertex. So in this case, the coordinates will be denoted by h comma k, and the standard equation is given as follows. So if the parabola opens upward, then the standard form would be the quantity of x minus h squared is equal to 4 times p times the quantity of y minus k. Now, for parabola opening downward, it is similar to the standard equation of the parabola opening upward, but for p must be negative. And then if the parabola opens rightwards, this time the variable y is actually squared. So that's why the equation is quantity of y minus k squared equals 4 times p times the quantity of x minus h. And then similarly for parabola opening to the left, the standard form is the quantity y minus k squared is equal to, this time it should be negative 4 times p times x minus h. Now in this standard form of the equation, the variable p is the distance between the vertex and the focus, and it is also the distance between the vertex and the directrix. Now to illustrate this using a graph, now we have the following. So if the parabola opens upward, then the vertex is the lowest point of the parabola. And then the focus is located above the vertex, while its directrix is located below the vertex. So in this figure, we can see that if the vertex has coordinates h comma k, this will be the coordinates of the focus. So that means we're going to add p units to the y coordinate of the focus. While the equation of the directrix, so since the directrix is horizontal, its equation is y equals the value of k minus the value of p. Now the axis of symmetry is the perpendicular uh, segment or perpendicular or the line perpendicular to the directrix that passes through the vertex, and its equation would be x is equal to h. Now, if the parabola opens downward, the vertex is the highest point of the graph, and its focus is located below the vertex. And its coordinates will be h comma k minus p. While the directrix is located above the vertex and its equation is y is equal to k plus p. And then its axis of symmetry has equation x is equal to h. Now, if the parabola opens to the right, now the vertex is at the leftmost point, while its focus is located to the right of the vertex. And since uh, the focus is located to the right of the vertex, then its coordinates would be h plus the value of p, comma k, while the directrix is located to the left of the vertex. And its equation is x is equal to h minus p. For the axis of symmetry is horizontal this time, so we have y is equal to k as the equation of the axis of symmetry. Now, if the parabola opens to the left, the vertex is at the rightmost point, while its focus is located to the left of the vertex. And its coordinates would be h minus p comma k, and the directrix is located to the right side of the vertex. And its equation is x is equal to h plus p. Now, the axis of symmetry is the horizontal line passing through the vertex and is perpendicular with the directrix. And and this line has equation y is equal to k. Now, how do we graph a parabola? So to graph a parabola, we follow the following steps. We first write the equation in standard form to determine its orientation. So for example, if we have something like x minus 3 quantity square is equal to 8 times y plus 2, we can see that x is the one that is squared, and the right side has a positive coefficient, which is 8. So this means if we go back to our equations earlier, it actually follows the form of the following. So we see that if the equation is written in the standard form, we can easily determine its orientation. So which means that this example here is a parabola that opens upward. Now, since the equation is in standard form already, then we can easily determine the vertex by identifying h and k. So in this case, the vertex has coordinates 3 comma negative 2. And then we can also determine the value of p. So since in the upward orientation, this coefficient 8 will be equated to 4 times p. So if we divide both sides by 4, we can determine that p is equal to 2. So once we have the orientation, the vertex, and the value of p, we can now plot the vertex on the Cartesian plane. And then depending on the orientation, we plot the focus. So if the parabola opens upward, then the focus is located above the vertex. So you have to count p units uh, going up not to get the focus of the parabola. And then afterwards, from the focus, we are going to form or we will plot two additional points, which we call point L and point R. And these L and R are actually the endpoints of the so-called latus rectum. So if the parabola opens upward, the location of the points L and R would be to the left of the focus, and the other one is to the right of the focus. And the distance of the focus with these endpoints of the latus rectum is 2 times p. And then we connect the vertex and the endpoints L and R forming a parabolic pattern, now depending on the orientation of the parabola. So let's have an example. So suppose that we have the equation x minus 2 quantity squared is equal to negative 8 times y plus 1. So from the given standard form, we can see that x is squared, so which means the parabola opens either in the upward or downward direction. However, since this one is negative, then we see that the parabola opens downward. And then the vertex will be 2 comma negative 1 because in here h is equal to 2, while since this factor is y plus 1, this can be written as y minus negative 1, which indicates that k is equal to negative 1. And then we solve for the value of t. So since the parabola opens downward, we shall use negative 4 times t and equate it with negative 8. So this indicates that t is equal to 2. So to graph this parabola, we plot the vertex. So the vertex is at 2 comma negative 1. So from the origin, you move 2 units to the right and then 1 unit downward to get this vertex. And since the parabola opens downward, then the focus is located below the vertex. So we have to count 2 units downward to get the focus. And then from this focus, we have to get the endpoints of the latus rectum. So the endpoints will be at the left and at the right side of the focus. So in this case, the distance between the focus and L and R would be 2 times T. So if T is equal to 2, then 2 times T will be 2 times 2, which is equal to 4. So from the focus, we have to move 4 units going to the left to get the endpoint of the latus rectum, and then 4 units going to the right to get the other endpoint of the latus rectum. And then we connect this L, V, and R by a parabola that opens downward. Now for the directrix, the directrix is actually located above the vertex as the parabola opens downward. And the distance of the vertex with the directrix is also P equals 2. So if we count 2 units upward, then we have to draw a horizontal line for the directrix. So this horizontal line here has equation y is equal to positive 1. Okay, and then the axis of symmetry is the line perpendicular to the directrix, and that line passes through the vertex and the focus. And this axis of symmetry has equation x is equal to 2. So this is the graph of the parabola x minus 2 quantity square equals negative 8 times the quantity of y plus 1. Okay, next. So this time, let's graph the parabola y squared plus 6 times y plus 8x is equal to negative 25. So this equation is in the general form. So in order to graph this parabola, we need to write this first in the standard form. So since y is squared and there's a missing x squared, then this parabola is a parabola that opens either to the left or to the right. So in order to transform this in the standard form, we need to group all those terms with y. And then we are going to leave a space here because we are going to complete the square later on. And then we will transpose 8x to the other side. So everything else must be transposed to the other side. So we get negative 8x minus 25. And then we will complete the square. So in this case, since the coefficient in the middle term here is 6, we will divide that by 2, which is 3. And then we are going to square 3, which is 9. So we are going to add 9 here. And since there's no, the coefficient here is 1, that's going to be 9 times 1 is 9. So we have to add 9 to the right side. So the left side now is a perfect square trinomial in which we can factor as y plus 3 quantity square. while the right side will now be negative 8x, and then minus 25 plus 9 is negative 60. Okay, and then finally, to fully write this in the standard form, we need to factor out the coefficient of x, whatever it is. So we have y plus 3 quantity square equals, so negative 8 will be factored out, and then we have x plus 2 as the other factor. So in this case, now we say that the parabola opens to the left. Now that's the orientation because y is squared and this thing is negative. So the vertex of this parabola has coordinates negative 2 because this is x minus negative 2. And then the other one, or the value of k, will be y minus, the value of k will be negative 3 because this can be written as y minus negative 3. And then for the value of t, we need to use negative 4p since the orientation is to the left, and then we equate it to negative 8. So if we divide both sides by negative 4, we get t is equal to positive 2. So to graph this parabola from the origin, we plot the vertex by moving 2 units to the left and then 3 units downwards to get the vertex. And since the orientation is to the left, that means the focus is located to the left of the vertex, and we count t units going to the left. Since t equals 2, we count 2 units to the left of the vertex to get the focus. Now, the endpoints of the latus rectum will be above and below the focus since the orientation of the parabola is to the left. So that means we need to compute for 2 times p. And in this case, it's going to be 2 times 2, which is 4. So from the focus, we will count 4 units going upward to get the endpoint of of the latus rectum. And then from the focus, we again move 4 units downward to get the other endpoint of the latus rectum. And then we connect the points L, D, and R by a parabola um, opening to the left side. Now, the directrix is actually to the right side of the vertex, and it is 2 units to the right of the vertex. And the directrix here is vertical, and this is um, x is equal to 0 or the x-axis. So in this case, the x-axis is the directrix. While the axis of symmetry is the horizontal line passing through the focus and the vertex and is perpendicular with the directrix. And the equation of this axis of symmetry is y is equal to negative 3. So this is the graph of y squared plus 6y plus 8x equals negative 25. So now for the next examples, we are going to find the equation of a parabola given certain conditions. So in order to find the equation of a parabola, we need to determine the orientation, whether the parabola opens upward, downward, to the left, or to the right. And then we need to know the coordinates of the vertex, and we also need to know the value of t. So of course, if we find the equation of the parabola, we need to write it first in the standard form, and then eventually we can write it in the general form. So for this particular example, let's find the general equation of the parabola with vertex v, v negative 3 comma 2 and focus at f0 comma 2. So since we need the orientation vertex and t, and the given information already includes the vertex, so all we need to do is to determine the orientation and the value of t. So since the focus is given, and if we plot this vertex and focus, we can see that the focus is to the right of the vertex. Okay, so that means the orientation is opening to the right side. And then the distance, we know that the distance of the vertex and the focus is the value of t. So which means in this case, the distance is 3. So that means p is equal to 3. So in order to write the general equation, we first write the standard equation of the parabola that is opening to the right side. So if it opens to the right side, it is in the form y minus k squared is equal to 4 times p times x minus h. So the value of k is 2. So this will be y minus 2 quantity square. The value of p is 3. So this will be 4 times 3 is 12 times the quantity of x minus negative 3. But minus negative 3 would mean x plus 3. But in this problem, we're looking for the general equation. So which means we need to expand y minus 2 squared. And this will be y squared minus 4y plus 4 is equal to, the 12 here will be distributed to x plus 3. So that will be equals 12x plus 36. And then we will transpose 12x and 36 to the left side. So we get y squared minus 4y minus 12x minus 32 is equal to 0. So this is the general equation of the parabola given the following conditions. Okay, for the next problem, this time we find the standard equation of the parabola with vertex at V with coordinates 4, comma, negative 6. And then it passes through the point P with coordinates 6, comma, negative 5. So here again, we need to know the orientation, the vertex, and the value of P. So since the vertex is already given, it has the coordinates 4, comma, negative 6. And now since we have the vertex here, now if we have the vertex here, and then we have the point P, there are two possibilities here. So it could be that the parabola opens upward. It could be that the parabola opens upward, or it could be that the parabola opens to the right side. So in this particular problem, there would be two possibilities to solve this problem. Okay, so in this case, we can write first the equation for the standard equation for the upward parabola, that is x minus h quantity square is equal to 4 times y minus k. This is for the upward orientation. Now for the rightward orientation, we write it as y minus k square is equal to 4 times p times the quantity of x minus h. So solving for both cases here, we have x minus h, so h is equal to 4. So that's x minus 4 square is equal to 4 times p times y minus negative 6. So that's going to be y plus 6. Now for the rightward orientation, it will be y plus 6 quantity square is equal to 4 times p times x minus 4. So in order to solve for the value of p, we need to substitute the coordinates of the given point P, 6, comma, negative 5 to x and y. So if we are going to substitute it, we get 6 minus 4 square equals 4 times P times negative 5 plus 6. So in here we get 2 square, which is 4. And then here we have negative 5 plus 6 is 1. 1 times 4p is 4p. So this implies that the value of p is equal to 1. So in this case, the equation or the standard equation of the parabola will be x minus 4 squared is equal to 4 times 1 is 4 times y plus 6. So this is the equation of the parabola if it opens upward. But if it opens downwards, if it opens to the right, then we have to use this particular equation and substitute 6, comma, negative 5. So in this case, we have negative 5 plus 6 quantity square is equal to 4 times p times the quantity of 6 minus 4. So this is going to be 1 square, which is 1. And then we have 4 times p times 6 minus 2 is 2. So we have y1 is equal to 8p, which implies that p is equal to 1 over 8. So the equation of the parabola, if it opens to the right, would be y plus 6 squared is equal to 4 times 1 over 8, which is 1 half, times x minus 4. Okay, so again, we had two possibilities here because the orientation is not given, and according to the given information and the given figure here, there could be two possibilities for the parabola. It could be opening upward or opening to the right side. And then finally, we have the last problem. Find the standard equation of the parabola with latus rectum at L uh, with coordinates 1 comma negative 5 and point R with coordinates 1 comma 3, and it opens to the left side. So here we can see that we need to know the orientation, we need to know the vertex, and we need to know the value of P. So first, we need to know the focus. We know that the parabola opens to the left. So which means if this is the latus, the endpoints of the latus rectum, the midpoint of this line segment will be the focus of the parabola. So if we just get the distance of L and R, its distance is actually 8. So if we divide 8 by 2, that's going to be 4. So from the point R, we can move 4 units downward not to get this point here. And this point is the midpoint of the latus rectum. And this point is the focus of the parabola. Now, since the parabola opens to the left, the vertex must be to the right side of the vertex, right side of the focus. Okay. However, in order to locate the vertex, we need to know the value of E. And we know that the distance between the focus and one of the endpoints of the latus rectum is 2 times P. So which means this distance here is 4, which can be equated to 2 times P. So this indicates that P is equal to 2. So now, from the focus, we can count 2 units going to the right to get the vertex. And then this is the parabola that opens to the left. So the coordinates of this vertex would be this is 3 comma negative 1. So the vertex is 3 comma negative 1. So we can easily determine now the equation because we know the orientation. It is opening to the left. And the standard equation of a parabola opening to the left is y minus k quantity square is equal to negative 4 times p times the quantity of x minus h. So since k is negative 1, that's going to be y plus 1 quantity square is equal to negative 4 times the value of p is 2 times x minus the value of h is 3. So we get the quantity of y plus 1 square is equal to negative 8 times x minus 3. And this is the standard equation of the parabola given the following conditions. So this ends our video for the conic section parabola, and I hope that you learned the techniques on how to graph the parabola, how to determine the standard equation, and how to find the equation of a parabola given certain conditions. So please do not forget to subscribe to my channel, and thank you for listening.